In this next section, 10.3, we're going to look at the integral test, which is another way that we can determine whether a series converges or diverges. And before we get there, I've got this corollary from a previous theorem that says a series of non-negative terms converges if and only if its partial sums are bounded from above. So there's some number, some value that is going to be above its partial sums. The integral test says if we have a sub n, which is a sequence of positive terms, and each term there is going to be equal to f of n, where f is a continuous positive decreasing function of x. So that's a mouthful there. For all x values greater than or equal to some positive integer, then the series and the integral are going to either both converge or both diverge. So we're going to be looking at some integrals where we're going to have a bound of infinity. So we're going to go back to what we learned in chapter 8. Now, the integral test can be very useful, but there's times that there are other tests that we can also use. And when I go through some of the examples in this section, we'll look at some examples where we're going to use the integral test, and in other cases, it's going to be easier to use something else to find out if a series converges or diverges. This is just one more tool here in your tool belt. I do have a note, though, before I get into some examples that talks about a p-series. If you've got the p-series, which is the sum from n equals 1 to infinity of 1 over n to the p, it converges if p is greater than 1, diverges if p is less than or equal to 1. That p-series, this is something else that you want to mark, you want to make note of, because we will use this further on in this chapter. If your p is equal to 1 there, so you have 1 over n, that does diverge, but it's called the harmonic series. So if you ever read that term or you see that term harmonic series, it just is the series 1 over n. Now we're going to look at two examples here in this first video. The first one says use the integral test to determine if the series, which is the sum from n equals 1 to infinity of e to the negative 2n, I'm going to look to see if that converges or diverges. So we're going to look at the integral from 1 to infinity. Oops. It would help if my pen was turned on. There we go. Of e to the negative 2x d to the x, dx, not d to the x. So we're going to integrate that, and we've learned how to integrate this back in chapter 8. This is going to be the limit as b approaches infinity of the integral from 1 to b, e to the negative 2x dx. So if I've got e to the negative 2x, I need to have this to be times negative 2 dx. I need the derivative of this exponent here. And if I need a negative 2 to be inside the integral, I can put a negative 1/2 in front. So that way it's the same as just multiplying by 1. So I'm going to rewrite that as the limit as b goes to infinity of negative 1/2 times the integral from 1 to b, e to the negative 2x times negative 2 dx. So now we can integrate this. We've got the limit as b goes to infinity of negative 1/2 times e to the negative 2x, and we're going to evaluate that from 1 to b. So let me continue down here. The limit as b goes to infinity, I've got negative 1/2. E to the negative 2b, I can write that as 1 over e to the 2b minus, then we plug in a 1. E to the negative 2 is the same thing as 1 over e squared. As b goes to infinity, we've got 1 over e to infinity, so this first term here is going to go to 0. So I'm left with negative 1/2 times negative 1 over e squared, which is 1 over 2e squared. So here the series converges. Since this converges, since that integral converges, we know that the series also converges. Now I mentioned before, the integral test is very useful, but it's just one of our tools. Sometimes you don't need to use the integral test. Sometimes you might have something else that might be easier or quicker to use. And here it says which of the following series converge and which diverge. So I've got the series here from n equals 1 to infinity of 1 over 10 to the nth. We've done something, if not this exact series, we've done something very similar. This is just a geometric series. You could rewrite this. It's the sum from n is 1 to infinity of 1/10 times 1/10 to the n minus 1. So this is a geometric series with r equals 1/10. And if that r value, or if the absolute value of r is less than 1, then it converges. And obviously 1/10 is less than 1, so the series converges. So like I said, it's as useful as the integral test is, you don't have to use it, especially if you have something else that might be quicker.